For this review problem, we are asked to evaluate the given limit. We will do so using two approaches. For the first approach, we'll just use some algebraic simplification combined with limit laws. Now, looking at what we have here, limit as x approaches 0, well, if we look at the denominator, we see the denominator is approaching 0, which means we cannot directly apply our limit laws. Instead, we will first need to do some algebraic simplification. The easiest thing I can see to do here is in the numerator, we can rewrite 1 as x plus 1 divided by x plus 1, and this will allow us to combine the numerator into a single fraction. Doing so, we will have the limit as x approaches 0. In the numerator, we're going to have this common denominator of x plus 1, and we'll be left with 1 minus the quantity x plus 1, and this is all divided by x. Now, distributing the minus sign through, we see that we will have a 1 minus 1, so that what we're really left with here is minus x divided by x plus 1, all divided by x. So the x that we have in the numerator and the x that we have in the denominator are going to cancel with each other, and we are simply left with the limit as x approaches 0 of minus 1 divided by x plus 1. Now, when we plug 0 into the bottom, we're getting something that is not 0, so it makes sense to use our limit laws. Our limit laws tell us that the limit of a quotient can be written as the limit of the top divided by the limit of the bottom. And when we take the limit in the bottom, we can go ahead and break that up into two separate limits. So now the limit of a constant is that constant, and the limit as x approaches 0 of x is equal to 0. So the value of this limit is minus 1. For a second approach to evaluating this limit, let me just quickly recall for you that we define f prime of a to be the limit as x approaches a of f of x minus f of a, all divided by x minus a. And if we make the comparison to the limit that we have to the left, we can think of our f of x as being x plus 1 to the minus 1, and our value of a as simply being 0. The reason this is true is we could add a minus 0 on the bottom and just note that f of 0 is equal to 1. So the value of this limit will be f prime of 0. So all we need to do is to differentiate the given function. So this is a composition, which means we will differentiate via the chain rule. So we take the derivative of the outside function, evaluate it at the inside, and we multiply by the derivative of the inside, which gives us minus 1 over the quantity x plus 1 squared. Plugging 0 into this derivative gives us minus 1 over 0 plus 1 squared, which is simply minus 1.